it's time to take one of our rational functions that we've been working with and produce a graph using all the normal features, intercepts, holes, asymptotes, etc. So the first step is always to factor it. If it's not given to you in factor form, you're going to need that. So let's go through this and factor it out. And I notice right away that I have a GCF. Right? GCF is 2. And that gets around some of the more difficult parts of factoring. I can just rewrite this top as negative 2 times x squared minus 4x plus 3. Okay, and the bottom I'm not going to deal with just yet. We'll get back to that. Now let's factor it using what we know about trinomials or identities. We still have that negative 2 factor, but I need two numbers that multiply to positive 3, add up to negative 4. That's going to be, that's going to be x minus 3 and x minus 1 on top. On the bottom, this is just a difference of squares, so this should be quick for you. I hope you have these memorized by now. That's going to be x plus 1, x minus 1. Now, we should be able to identify certain characteristics of this function which go on our graph. First of all, let's point out that there is a hole in the function. Okay, that is something we can deal with right now. The hole is at x equals negative 1, and the y location of the hole is given this way. You evaluate f at the location of the hole. So the hole is at x equals 1, and we're going to say negative 2 times 1 minus 3 over 1 plus 1. And of course, we ignore that removable discontinuity right there. So this becomes negative 2 times negative 2 over 2, which is 4 over 2, which is 2. So the hole is located at, I'll write it this way, x comma y of the hole. We already found the x location, that's 1. And this is the y location, okay, that we just discovered at 2. So when you put that on your graph, here's how that's going to look. 1 comma 2. Okay, so that's x equals 1, y equals 2. You're going to use, okay, I drew a very, very large circle there, but you're going to use this feature right here to place that dot on your graph. Now, next part. Let me move this guy down to get it out of the way. We'll start working on whatever's next. I think vertical asymptotes would be a nice place to go. Or we could also do, it's really your preference. There's no particular order you have to go in. So let's just move on and do vertical asymptotes, because I mentioned that. So x plus 1, that is a factor that's on the bottom, but it is not on the top. So that means there is a vertical asymptote at x equals negative 1, right? I solved this equation, x plus 1 equals 0. So that means x equals negative 1. That's this vertical asymptote right here. And you would draw that using this line. Of course, I think you'd probably have a solid line show up on your graph when you do it. And then with the vertical asymptote out of the way, it's time to move on to our x-intercepts. So let's find some of those. I see a factor on the top, which is not on the bottom. That's an x-intercept. And that's just going to go at x equals 3. Because, likewise, when we solve this equation, just like we did for the vertical asymptotes, you get x equals 3. That's the location of the x-intercept. Now, we need a y-intercept. That'll be the last part of this. And this is one of the easiest parts. For the y-intercept, you just go back to the original unfactored equation and divide those last terms. So in this case, it's negative 6 over negative 1. That means a y-intercept at 6. Okay? And because we still have one more thing that we've been talking about in this unit, the horizontal asymptotes. Our graph isn't done yet. We can put a horizontal asymptote at this graph at a certain location, and either it's at 0 or it's someplace other than 0. Remember, if we're bottom heavy, it's at 0. In this case, it's not a bottom heavy equation. Those are x squared terms. So what I do is I use the ratio of the coefficients, which is negative 2 over 1, right? That's a 1x squared. So negative 2 over 1 is just negative 2, and that means our horizontal asymptote is going to go right here at negative 2. Okay? And if you were to graph this function, what it would look like, you don't have to graph it, obviously. I'm just pointing this out for your own personal satisfaction, I guess. It would look something like that. It would connect the dots and the hole, and you'd have another portion of the graph over here, but we haven't gotten into that.